we're now using a product like this. This is a water barrier that basically comes coated onto the sheathing, and it's an air infiltration and a water barrier all in one.
Our sheathing came to us from Commerce, Georgia, where they've been making building products for more than 30 years. It is a big and noisy facility, so we're fortunate to have the headsets to help us out, and very fortunate to have our plant manager, Mike, here.
Morning, Kevin. Great to have you with us here.
Yeah, well, thank you for the invite. So this is where it all starts, huh?
This is where it all starts. This is a Commerce, Georgia facility.
And so I look at all the feedstock back here. What species are you guys working with?
Southern yellow pine. We take it in from a 75-mile radius around the plant. We get about a little bit over 100 trucks a day.
And how many logs on each of those trucks?
About 28 tons.
28 tons.
28 tons.
Times all those trucks. All right.
And so we're singulating these logs one at a time, coming from our infeed deck, working their way up to the slasher deck, which is going to roll one log at a time into the conveyor. And this conveyor is going to then take the log down through a metal detector. We're checking for spikes, barbed wire, nails, anything that might damage our stranders in the process. This is a debarker. You see the feed rolls pulling the log into the machine. The log is going to be stripped of the bark.
And what happens to the bark?
It'll be the wet fuel for our furnace.
So what are we looking at here?
So right here we have a strander. It's a disc strander. It's like a big deli slicer in a sense. So we're taking the logs as they come in and creating dimensional pieces that we can use in our process down the line here.
So as I look behind me, these big iron bars coming down, they're holding the log in place while the cutter swipes across them?
That's correct. The hydraulics are holding the logs in place as the strander comes across, peels those strands out. It has 24 pie sections, and each one of those has 2 blades on it, so it has 48 knives on this strander. Those strander knives have to be changed out about every 6 hours before they dull.
That's a lot of sharpening and a lot of blade changing.
That's correct. So Kevin, this is where we set our knives up that go in the disc we just got finished looking at. This is a typical strand we see coming through the process. Again, about a 5-inch long, about 2 inches wide, and about the thickness of a business card is what we're looking for. Now, how do we get that strand out of the process of that disc? We have 48 of these knife blades inside that disc sticking out about the thickness of that business card to create that thickness there. The angle on the back side, which is called a counter knife, is what determines the width of that. So that angle, depending on how shallow or how gradual it is, creates the width, either a toothpick or I can create sheets of paper.
So already a lot of effort to get sort of this exact dimension.
That's correct.
Why is that so important?
The strand is the foundation of your panel. So getting the right strength characteristics in that strand, the right size strand, determines the strength of your panel at the end of it.
Gotcha. Oh, wow. So what are we looking at here?
So we're looking at our drying process here. We're taking the strands and we're going to run them through the dryer here. They started out at about 50% moisture content, and so now we have to dry them down.
If you're starting at 50%, what are you trying to get it down to?
We're looking at about 3 to 4% in our core and around 9 to 10% in our surface material.
So a lot of drying going on.
A lot of drying. We're going to go from about 1,500 to over 1,500 degrees Fahrenheit on the far end of the dryer to the front end would be around 300 degrees. Well, we have the formula line here where we're laying the strands, orienting them in the proper direction. We lay a bottom surface layer that is parallel. We'll have a core layer that will be perpendicular to the line, and then another layer on top that will be parallel.
And what does it do for you to have those layers come down parallel, perpendicular, and 3 of them?
So the reason to have them parallel and perpendicular is give you the bending strength and stiffness that we want.
Right.
It also gives us shear strength along with the density of that panel in that process. Also, in this product that we're making today, we have this integrated weather-resistant barrier. The green side is facing down. It provides an air barrier and a water barrier to the panel. Here in the control room, we operate both the drying process and the pressing process. He also controls the blending process, which is where the resin is integrated into our strands before they were formed on the mat. We're going to take this 5-inch mat we talked about coming down the line. Again, in this case, we're going to close it with over 4,000 pounds per square inch pressure. We're going to sit in that press at over 400 degrees Fahrenheit for 4 to 5 minutes.
Well, now they're starting to look like something I recognize.
That's right. They're going through a computer system that checks for surface quality. We also have gone through a blow detection device or delamination detection device, looking for delamination in the panel. And now these final A-grade panels are coming out with the logo and nail grid already installed. They're going down the line here, getting stacked up so they can be packaged. And at this point, we're putting them on the trucks, getting them ready to go to your project.
Nice. Mike, thanks a lot for the tour. Very insightful. We appreciate that, but we especially appreciate the material coming to the job site.
Thank you very much.
You got it. Thank you. Thanks for watching. This Old House has got a video for just about every home improvement project, so be sure to check out the others. And if you like what you see, click on the subscribe button to make sure that you get our newest videos right in your feed.